10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Beginning pitch over.
Electron is cleared to power to safe launch pad.
Stage 1 propulsion nominal.
All right, liftoff for Electron's 63rd launch, and we are on our way to space for this wildfire detection mission for OroraTech. Now at over coming up to 5 kilometres above Earth and travelling at over 900 kilometres an hour. Soon you will hear our operators announce Max Q, the point in the rocket's ascent that it experiences the highest aerodynamic stress. So let's listen in for that call.
Cleared Max Q.
At T plus 1 minute 15 seconds and counting, that is Max Q cleared by Electron on its way to space. Telemetry is looking good, with Electron now traveling faster than the speed of sound at more than 2,000 kilometers per hour. Next up is MECO, or main engine cutoff, followed by stage separation and then second stage engine ignition. MECO is when all 9 Rutherford engines shut down to slow Electron's pace just before the second stage separates. Once that happens, the engine on stage 2 will power up to continue the momentum to orbit, with the engine burn running for several minutes to propel the second stage with its payload. Let's watch it all unfold on our screen in just a few seconds.
"15 seconds to staging.
Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
There we go. That was MECO, stage separation and second stage ignition as planned and confirmed, but what we heard across the nets and saw from Electron's onboard cameras. Travelling at more than 8,000 kilometres per hour now, up next is fairing jettison to separate the nose cone from the second stage. Let's stay with mission control and see if we can catch a glimpse of them too as they fall away.
Fairing jettison confirmed.
By fairing and hello space for OroraTech satellites, now exposed to those vacuum conditions above Earth as the mission continues nominally.
AGB discharge holding nominal.
Electron's second stage Rutherford engine is continuing nominally, keeping the mission on track towards its target 550-kilometre circular Earth orbit. Now, the engine has a 6.5-minute burn time before its scheduled stage separation with the kick stage at T plus 9 minutes and 5 seconds. So now that we are at T plus 4 minutes, nearly 5 minutes and counting, that leaves us with another 3 to 4 minutes or so to go in the countdown to engine shutoff.
Some things you'll hear from Mission Control shortly will be HVB battery discharge nominal and approaching hot swap, both of which are callouts related to the battery packs connected to the second stage's Rutherford engine. Those batteries are keeping the mission moving as they power the electric pumps that provide both fuel and oxidizer for Rutherford's combustion. But like all batteries, the longer you use them, the more they drain of power. With the second stage engine burn lasting longer than its first set of batteries, Electron performs a switchover that taps into the next set of batteries while the engine is still running. The maneuver is called the hot swap, and it's a critical next step in the second stage's journey to orbit. Let's watch and listen.
Guidance is nominal, 200 seconds remaining.
HEB discharge holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Battery jettison confirmed.
There we go. That is battery hot swap confirmed from what we heard and have seen just now. The mission is continuing nominally along its trajectory, now past 200 kilometres in altitude and getting close to its required orbital speed of around 27,000 kilometres an hour.
AFTS has saved.
We have about 2 more minutes left in the second stage engine burn before Electron reaches its nominal transfer orbit and separates the kick stage with its satellites. This refers to the planned and expected trajectory the mission will follow when moving from one orbit to another.
Because the kick stage is released in an elliptical pattern, a transfer orbit will bring the kick stage to the altitude of its planned circular Earth orbit. And that journey takes about 40 minutes or so from the moment the kick stage is separated from the second stage. Now, once the kick stage reaches its target, its own engine will light up to perform additional maneuvers that circularize its altitude for that desired payload drop-off.
Before that happens, first we have to pass through engine shutdown on stage 2 and the final stage separation. It's a similar process to what was achieved with Electron's first and second stages just minutes ago. Stage 2's engine will throttle down and shut off in preparation for separation before the kick stage is released and sent on its way with OroraTech satellites.
Entered burnout detect mode.
Guidance is in terminal, 20 seconds remaining. Seco confirmed.